In this episode, we're going to look at how to secure network devices. I'll show you how to do it, and we'll talk about the concepts along the way. In this activity, we're going to configure our router and a switch based on a list of security requirements. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Secure network devices. I've loaded up the Packet Tracer Lab. On the left side, we have our work area where we'll go and configure our devices. On the right side, I have our activities and the instructions. The bottom right is the actual Packet Tracer activity windows. That has all the requirements in there. I keep that open because I use the check results there to see what I'm missing when I'm done with the lab, so that way I can get 100% completion on the lab. I have the Word document open up here of the instructions, and what this Word document does is it allows me to enter in my answers and save it. And so in this lab, we have to come up with the default gateways here for this. The Word document will allow me to enter that information in the addressing table, and then I can save that from there. We have our network. Once I open up the Packet Tracer, I did have to wait about 30 seconds for all these little switch ports, all the connections into these switches to go through their auto negotiation process. When I first started, these were orange or yellow circles. I had to wait until they turn green. Once they turn green, I'm good to go to start on the lab. As we get into this lab, there is a note here to pay attention to. To keep this lab brief and easy, some of the security configurations haven't been made. And so we don't fully lock down our devices like we should in a production environment because we are trying to learn some of this. In other places, security best practices haven't been followed, as in setting up all the passwords on all of the devices. We're only doing some parts, and you're being checked on the parts you're asked for, and that's where the completion comes in. Is if you follow the lab here and do exactly what they say, you'll get 100% completion. We have our instructions here. First step, step 1, document the network, complete the addressing table and the missing information. If we look up here, we have our addressing table. We have router A's information for the gig 000 interface and the gig 001 interface. We have the switch information for our SVI, our VLAN 1 basically. We have an IP address, we have the mask, but we don't have a default gateway. We have to figure out what the default gateway is. If we look over here at our topology, we see that switch 1 is connected to R1, and this is all one network. The laptop, the PC, switch 1, and this connection on router A, that is all one local area network. And the default gateway from this network onto a different network is this interface at this point in time. If I mouse over the green triangle closest to where that is, we can see that it's the gig 000 interface that is connected to that. And that IP address for the gig 000 interface is the default gateway for this network over here. If we look at our addressing table, here's the gig 00 interface. This is the IP address right here. That is our default gateway for our switch, for our PC, and for our laptop. And so here is our switch. Here's the gateway field. I can go ahead and enter in 192.168.1.1. That's our default gateway. For our PC, once again, our PC is still on the same local area network, so it's going to have the same default gateway, same exit point on and off the network. 192.168.1.1. Here we have the laptop. Laptop, once again, is on the same network, same exit entry point onto the network. That's the gig 000 interface. IP address 192.168.1.1. And then our remote PC. The remote PC is on a different network. Once again, these routers here divide up networks. They connect two networks up. And so every wire coming off of a router is a different network. The remote PC is on a different network. If we look here, it's on this router, it's on this network, it comes up to this interface right here on the router. That's our exit point on and off. The IP address here, if I mouse over the green triangle, if I mouse over it, I actually had to click in the window and then mouse over it. It's telling me that this interface is the G001 interface on router A. Come over to our addressing table. Here's G001. Here is the IP address. Now notice the subnet mask goes through the first 3 octets for both of these addresses, and it is a different network. The 3rd octet is a different number, which is all part of the network address. This makes it 2 separate different networks. And the default gateway for this network, the upper right one, is going to be different than the lower network. It is the G001 interface for the upper network. Look at it. This is the IP address here of our default gateway, 192.168.2.1. Go ahead and you can type that in, 192.168.2.1. There we go. We've completed our addressing table. That takes care of step 1. On to step 2, router configuration requirements. Now this lab is about checking that you understood all the previous labs. The lab doesn't give you the step-by-step instructions, and so you should hopefully have done them enough where you memorize them, but being realistic, you probably haven't. This would be a great place to go in and check your notes. As you configure these devices, you should be writing these commands down, so that way you have some sort of command reference guide to come back and look these commands up pretty quickly. First step, 2A, prevent iOS from attempting to resolve mistyped commands into domain names. That's stopping that DNS lookup. And so we're on router configuration. I'm going to go ahead and click on router A. Opens up our command line interface. Here it is. Hit enter a couple times, give us into user exec mode, type enable, gets us into privilege exec mode. And then in order to do that first requirement, we need to be in global configuration mode. I'm going to go ahead and type config T, hit enter. Notice our prompt has changed. This tells us we are in global configuration mode. From here, we can go ahead, enter in the command that prevents the iOS from resolving domain names. That, once again, that is no space IP space domain dash lookup. There you go. You hit enter, and once again, in true Cisco fashion, if you enter it incorrectly, it's not going to let you know. If you enter it in incorrectly, Cisco's iOS will definitely let you know. So no news is good news here in the Cisco operating system. On to the second one. Set up host names that match the values in the addressing table. Well, we're on router A. This is the name. Capital R, capital T, capital R, dash A. Go ahead, we'll set our host name to that. RTR-A, all capitals. Go ahead, hit enter. And notice once again, our completion is increasing as we're entering this in. I'm up to 4% completion. Require that newly created passwords be at least 10 characters in length. We have to come in here and set the minimum password length. It's a security requirement. And so that command here is security space passwords space and then min length, because that's what we want to set. Here's min length, and then we give it a number. That number is that minimum length. Go ahead, hit enter. If you notice, I typed it in wrong. Cisco wasn't afraid to tell me. They actually gave me a little caret sign right here to tell me where my problem was. I forgot the word, or I forgot the letter N in the word length. What I'm going to do is I hit the up arrow once, brings up the old command. I am going to left arrow over to where the N has to go. Type in the N, hit enter. I got the command right. Cisco operating system was happy. How do I know? No news is good news. Next one, a strong 10-character password for the console line. Use at capital CONS 1234 exclamation mark. Now that's our line console window, or sorry, our line console configuration. So right here from global configuration mode, I can go ahead and type line con 0. At that, go ahead and hit enter. Notice how our prompt has changed. We are now in line configuration, and then we have to set the password. And that starts off with the keyword of password, and then what we want it to. This is what they wanted to set it to. Once again, for Packet Tracer, you have to set it to exactly this to get credit for it. And we have @ capital CONS1234 exclamation mark. Hit enter. I did it successfully. The operating system was happy because it did not complain. No news is good news. Then, once we set the password, we also have to tell it to use it for the login process. We set the password. Now, once it's set, we have to say, okay, during login, use this password. And that's just simply typing login at that point in time. Go ahead, exit out of the line configuration. That takes care of this line. On to the next line. Ensure that the console and VTY sessions close after 7 minutes exactly. So if you're privileged exec mode, if your console or VTY sessions remain idle for exactly 7 minutes, we're going to close that. Now we have to go back into our line console 0, line con 0, and then that command once again is exec -timeout. So for privileged exec mode, what is the timeout? Is 7 minutes. And you can also specify seconds because we want it to be exact. What I'm going to do is have the 7, I put a space, and then 0. Exactly 7 minutes and 0 seconds, it will log you out. That sets that. Now we have to do the VTY passwords. We don't have to exit out and then put in line VTY 04. We can just change the lines right here. And so I can type in line VTY 0 space 4. And then it's the same command we just entered. Exec -timeout. First number is minutes, second number is seconds. Exactly 7 minutes, it will log you out. And there you go. That takes care of this requirement. On to the next requirement. A strong encrypted 10-character password for privileged exec mode. For this activity, it is permissible to use the same password as the line console password. Basically, they want us to get into privileged exec mode. They want us to use this password. And so we have to get out of line configuration mode. I type in exit once. Go ahead, hit that. And then once again, our command here is enable. And then the option of secret, because we want the password to be encrypted. And then we type in our password. capital CONS1234 exclamation mark. I go ahead and hit enter. That sets our password at that point in time. Then it asks us to set a message of the day banner that warns about unauthorized access to devices. I'm going to go ahead and set that. The commands here once again is it's a banner command. We want the message of the day, MOTD, and then you have to put a delimiting character in there. And typically what I use is the $, then you put your message. At the end of the message, you put that delimiting character again. And so anything between those two characters, and they have to be the exact same characters, that's going to be published as the banner message of the day. And so we're going to say unauthorized, yep, I spelled that right, access prohibited. And put a period, and then once again we put our delimiter in there, our $, that we used. Go ahead, hit enter, and I have an error. I spelled banner wrong. Up arrow once, left arrow over, make the correction, and there we go. We have now set our banner message of the day. That takes care of this requirement. Password encryption for all passwords. At this point in time, this is where we want to encrypt all of our passwords in our running configuration. Even if they're stored in plain text, we're going to run a service here that encrypts that. And the command, once again, is service space password encryption. There you go. Once again, I typed it in. How do I know? No news is good news. That takes care of this requirement. Now, we have to create a user here called netadmin with the encrypted password of logadmin exclamation point 9. This is done here in privilege executive mode, or sorry, global configuration mode. This is done in global configuration mode. Start off with the command username, the keyword in there. Then we put what we want to be the username, capital N, capital E, capital T, A, D, M, I, N. Then we say, we could either say password or secret here. Because we want it encrypted, we're going to say secret, because that will encrypt the password. And then they want this to be our password right here, logadmin exclamation mark 9. And so I go over here, I type capital L O G capital A D M I N exclamation mark 9. Go ahead, type that in there, hit enter. That creates the user. No news is good news. We've created that. Now we need to enable SSH, and there's a couple steps we need to do in order to enable that SSH. First one is we need to set a domain name. The domain name we're going to set here is security.com. And so that command here is IP space domain dash name, and then what we actually want to call it, and the requirements say we need security.com is our password. Go ahead, hit enter. That sets our domain. No news is good news. And the other thing is we have to set the modulus, the encryption key, to 1024. That command deals with cryptography, so we start off with crypto space, then we want to have the key and generate it, so it's key space generate, and then using the RSA algorithm, go ahead, hit enter, and it's going to say how many bits would you like the modulus to be. We want the modulus to be 1024. Once again, 1024 is required for SSH version 2. If you don't have that, a lot of today's SSH clients won't connect unless you have at least 1024 bits as your modulus. Don't take the default of 512. Don't hit enter at this point in time. You have to enter in 1024 and then hit enter. Generates your RSA key. Takes care of this step. Now we're moving down here. The VTY lines should be used for SSH incoming connections. What we have to do is go into our virtual terminal lines and set it up to use SSH. And so from global configuration mode, I can go ahead, type line VTY space, and then once again we have to do the range. We're going to do 0 to 4, take care of the first 5. If we do just 0 at this point, lines 1 through 4 would be wide open and not require SSH. They could use Telnet at that point in time, but we want to do the first 5 lines, so make sure you do line VTY space 0 space 4. I hit enter. Notice it does say SSH is enabled. I did get that system message here. Now we actually have to say, okay, anytime anybody uses a virtual terminal to connect to us, let's force that transport input to SSH. Command here is transport. We're dealing with how that data is transported back and forth. We're using input and SSH. That sets that up to use the SSH we just configured. The VTY line should use username and passwords that were configured to authenticate the logins. And so up here they had us set up the netadmin username and password. Now we actually have to tell it to use that. And once again, this password we created is in the local security database. It's in the local database. And that command here is for our login process. And then where are we getting that information? We're going to use our local database. Now we could have an AAA server in there. You could have a number of other servers that have username and passwords in them. Right now we're just using the database that's on our device where we went and created that user. Go ahead, hit enter. There we go. And the last step, impede brute force login attempts. That's a brute force login. They're trying to get into our system by going through sequentially guessing numbers. Attempts using a command that blocks login attempts for 45 seconds if someone fails 3 attempts within 100 seconds. Okay, so what we're looking at here is a configuration requirement here for our line VTY0. And so what we can do is say login and then block -4 login. Oh, it's not on the line, it's in global configuration mode. I need to exit out. Now login space, and then I put a question mark, and you can see block 4 is part of this. And so that's what we're doing. We want to block it for -FOR, and then the number we give it right there is how many seconds do we want to block it for. Over here in our requirements it says 45 seconds, and so the number we put in is 45. Then we're looking at if someone has 3 failed attempts, and so the next option is attempts, and at 3, because that's what the requirements say, we are going, and if they had, and if those 3 failed login attempts happen within, so that's our next option, of 100 seconds. And so we put that information in there. I go ahead, hit enter. There we go. We have that set up. How do we know Cisco liked it, the operating system? No news is good news at this point in time. That takes us through all the configuration for our router. At this point in time, I have a completion of 47%. I'm just going to go ahead and click on check results. Click on the asset items. Looking here, router A, I see we have all green check marks under router A. That's good. We have successfully completed everything for router A. I'm going to go ahead and close the assessment items, the check results window. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. On to step 3, switch configuration requirements. Now we're going to go ahead and configure the switch. First thing we probably need to do is give us a host name. And we are dealing here with switch S1. So I'm going to go ahead and click on switch S1. Gives us our command line. Hit enter a couple times. There we are. Type in enable, get us into privileged exec mode. First thing that they want us to do is all unused switch ports are administratively down. All unused ports we're not going to use. If we look over here, we have 3 wires, 3 ports are being used in switch 1. If I put the mouse over switch 1, I can see that, oh, I gotta leave it on switch 1. I can see that Fast Ethernet 02 is up, meaning we have a wire plugged into that. I can see that Fast Ethernet 010 is up, meaning we're using that one. And Gigabit Ethernet 01, we are using that one. So Fast Ethernet 2 and 10 we're using, and Gigabit Ethernet 1 we are using. All the other ports we need to make it administratively down. And how we can do that is using the interface range command. So we have to shut down Fast Ethernet 1, 3 through 9, 11 through 24, and Gig 02. Okay, hopefully I'll remember that. From our privileged exec mode, we need to get into global configuration. Then we now enter in our interface range command. So interface, or INT, range, and then we put in all of our ranges. All of our ranges again here. Fast Ethernet 01. And so F0/1. You can put a comma because we can put multiple ranges in there. Then we go Fast Ethernet 3 through 9. So F0/3, and then put a dash, the minus sign, to 24. No, it was through 9 because we're using 10. Let's go over here and confirm that. Yep, that's using 10. This is using 2. And then this should be using gig 01. Then the next range, coming back over here, clicking in the window, mousing over switch 1, is from 11 to 24 for our fast Ethernets. And so F0/11-24, and then finally we have to do that last gig port. And just to confirm again, click in the window, mouse over S1, we're using gig 01, so we have to shut down gig 02. And so that is G0/2. You can have different ranges all put together. Go ahead and hit enter. Notice our prompt is now changed. We are now configuring a range of interfaces. That's what we're doing. This range that we just specified up there. Well, at this point, once again, we have to disable them. Go ahead and type shutdown. And all of those ports shut down. We can scroll up and we can see 1, 3, 4, 5, 6, 7, 8, 9. We're using 10 over here. 11 all the way to 24 went administratively down, and then gig 02 went administratively down. We shut down all those unused ports. On to the next step here in step 3. The S1 default management interface should accept connections over the internet. Use the information shown in the address table. The switch should be reachable from remote networks. And what we're looking for here is configuring our V1, that management interface that allows us to connect into our device, and do that using SSH or Telnet. Once again, please don't use Telnet, always use SSH. And I'm going to go ahead and click on S1, bring that back up. We are in that interface range. I'm going to go ahead and type exit at that point. Now we need to go into the interface of VLAN 1. That's our management interface. So I type int space VLAN 1, hit enter. Notice now we are just configuring a single interface at this point in time. We need to make it reachable, so we have to go and set an IP address on it. Up here for switch 1, our switch virtual interface has the IP address 192.168.1.254. 192.168.1.254, and of course we need to put our subnet in here. Our subnet is a /24 or 3255s, 255.255.255.0. There we go. Up, and I forgot the keywords at the beginning. I'm going to use the up arrow once, arrow over all the way to the left, type in IP space address, and then leave that address as is. Go ahead, hit enter. And our IP address is set. Anytime you do anything with an interface, get in the habit of doing a no shutdown on it. Just to turn it on. VLANs are off by default, so you have to go in and do your no shutdown on it. There we go. Notice interface VLAN 1 changed state to up. Our LAN protocol has changed state to up. We have turned that on. Then the last thing we have to do here is it should be reachable from remote networks. This means you have to make sure you set your default gateway. If I scroll back up here underneath switch 1, we have a default gateway. That's one of the fields we had to fill in earlier. Here's our default gateway. That's our exit on and off the network. Now, a default gateway is not associated with an interface. It's associated with the entire device. And what we have to do is get out of the interface configuration mode and get into global configuration mode. So I'm going to go ahead and type exit, hit enter. Notice our prompt right now just says config. That is our global configuration mode. From here, we can go ahead and set our default gateway. It's part of the IP protocol, so we start off with IP space and then default gateway, default dash gateway. And then you put the IP address of our default gateway in there, 192.168.1.1. Hit enter, and no news is good news again. That takes us through the second bullet point right here onto the third one. Third one is use this as the password for privilege exec mode. We're going to go ahead and set that, and that is enable space secret, because we always want to encrypt it. We use the word secret instead of password there, and then we put our password in there. @ capital CONS 1 2 3 4 exclamation mark. There we go. We have it set. I hit enter. We have now set our privilege exec mode password. We need to configure SSH as we did on the router. Once again, there are several steps we need to do to configure SSH. First thing we need to do is set a domain name. That command here is part of the IP suite again. So you start off with IP and then domain name, domain-name, and then what we want to give it as our domain name up here, we use security.com. So let's go ahead and use security.com. Hit enter. No news is good news again. Still configuring SSH. Now we set our domain name. We have to do our crypto key. We have to generate our key. Right here, we use the modulus of that. The command here is, starting off, is crypto, because it's part of the cryptography package. We are working with our keys. We want to generate it using the RSA method. At this point in time, I'm going to go ahead, hit enter. Please define a host name other than switch. We need to go ahead and set our host name. So host name space. I'm going to scroll up here, see what they want us to use it. SW-1 is our host name. I'm going to go ahead and enter that in. Capital S, capital W-1. There we go. We have now set our name. We should be able to enter in this command again. I'm going to hit up arrow once, hit up arrow twice. There it is. I hit enter. It's going to say this is the name of the key. Gives us right there. And here it is. How many bits would you like your modulus? Once again, we want to make sure our modulus is 1024 bits long. So let's go ahead and type that in. 1024, hit enter, and it generated our key for us. So we set up SSH. Now let's create a username so that way we can use it to log in. It's the same credentials as above. That command once again was username space what you want it to be, the username. So capital N, capital E, capital T, ADMIN space. We want to encrypt our password for that, so we use the next option of secret, and then what we want the password to be. Capital LOG, capital ADMIN, exclamation mark 9. Go ahead, hit enter. Now it says because we've done our username, it didn't get any complaints, so we did that correctly. And we have now completed all the requirements for SSH, and SSH has been enabled. Taking us down to here, the next one, the VTY line should only accept connections over SSH. That means we need to go into our virtual terminal configuration. So line space VTY space 0, and make sure to do that range 0 space 4. We are now in line configuration mode, only accept connections over SSH. We're looking at the transport space input space SSH. That command will force only SSH. Telnet will not be allowed. Hit enter. The next line here, the VTY line, should only allow the network administrator account to access the switch management interface. So the switch management interface, that's our virtual terminal line. And we want them to log in with the user we created right here. So we have to tell them to use that local database for logging in. And so the command here is login, and then any sources you want for those usernames, we're just going to use the local database. I'm going to go ahead and hit enter, and that set that one up. That takes us down to here. Last thing is hosts on both LANs should be able to ping the switch management interface. And what we're looking at is all of our three PCs, PC, laptop, and remote PC, should all be able to ping the management interface on the switch. Management on interface has 192.168.1.254. So I'm going to go ahead, open up PC here, open up our command prompt, type in ping, and then the IP address of our management interface, 192.168.1.254. 92.168.1.254. And failed on the first time. We had to go through the ARP process to get the MAC address to send the communications across the network. Then all three worked. If I do up arrow again, all four will work this time because our ARP cache has the destination MAC address known. Go ahead and close that out. Open up my laptop. We'll do the same thing. Open up the command prompt. Type in ping space 192.168.1.254. Might time out again. Did time out, but 2 through 4 worked. Up arrow again, just to confirm all 4 worked. There we go. And finally, the big test. I'm going to come over here, click on remote PC, open up my command prompt, and ping that interface one more time. Ping space 192.168.1.254. First request timed out. Second request timed out. Third and fourth one did. It took a little bit longer to go through the ARP process, but it eventually worked. I'm just going to confirm it. Up arrow once, and all 4 pings are working. That is the lab completed. That was the last step. That was Packet Tracer Lab 16.5.1, Secure Network Devices. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.